Let's take a look at example 2. So let's see it again. It says locate the vertical asymptotes and sketch the graph of y equals negative tangent x over 4. So notice this has a vertical transformation, but this vertical transformation will not affect our asymptotes. So for graphing, it will. When I first started at the beginning of the lesson, I told you tangent goes up and to the right. This one goes down and to the right because of the negative. However, that negative does nothing to my asymptote. It technically flips the asymptote, but that doesn't change anything. It's still moving straight up and down, even after you vertically reflect it. So that's going to have zero change in our problem. So we'll use our same 3 steps that we had before. Number 1. What was step number 1?
Find the ratio.
Find the ratio of your trig function, which in this case is tangent. Tangent's ratio is y over x. Go ahead and just say it. It's y over x. Okay. If we're finding a vertical asymptote, what does that have to do with the ratio? What creates a vertical asymptote?
X equals 0.
Dividing by 0. That's right. So we want to search for when x equals 0. That's what I'm looking for. So step 2. This is where I use the unit circle. The unit circle, we're going to check when does x equal 0. So we'll come over here. And we've already had this one 3 times today. Where does x equal 0? Pi over 2. Again, 3 pi over 2 would also work. I'm just going to use pi over 2 though. I always just do the first one because it's smaller numbers. So now I know that it's at pi over 2. Let me change that to blue. Pi over 2. I just changed colors just to show you that when I get to step 3 is where we apply horizontal transformations. When we apply these, I'm going to start with that blue. So it's always x equals pi over 2 plus n pi. That's how you start. So like if there was no transformations at all, if it was just tangent, that would be the solution. But this has transformations. The horizontal are all I'm concerned with. I'm not concerned with the vertical. All I'm concerned with are the things that are affecting the x. On this problem, if you wanted to write it down, b, technically your b is 1/4. But the easiest way I think to think about it is to say, what is the b doing? And do the opposite. What are we doing with that 4 right there? What's it doing to x?
Dividing.
Dividing. What's the opposite of dividing?
Multiply.
Multiplying. And when you multiply or divide, you do all the pieces. So I multiply and I get 4 pi divided by 2 plus 4n pi. And I can simplify that. What's 4 divided by 2? 2 pi plus 4n pi. And again, this would be where n is an element of the integers. So n is a double z. That's just saying n is an integer right there. That's all that's saying. Integers are whole numbers, but positive and negative whole numbers. Okay, so let's check this out. This is saying that our first asymptote, I'm trying to explain this to you now, should occur at 2 pi. So if I look at my picture, my first asymptote should occur at 2 pi. This is if n is 0. So if n is 0, that goes away and we get an asymptote at 2 pi. Notice 2 pi. Okay, what if n became a 1? Well, if n is 1, then that means we would have 2 pi plus 4 times 1 times pi. Let's do a little quick math in our head. What's 4 times 1? 4. So what's 2 pi plus 4 pi? 6 pi. You see how they got that? And going left, this would be like -1. So you'll learn, if you're not in physics already, that whenever you take physics, which I highly recommend to you, that negative typically, when we're talking about x-axis values, means go left. So we could find these going left. -1 means the asymptote 1 to the left from our original. This would be x equals 2 pi plus 4 times -1 times pi. 4 times -1 is -4. So 2 pi minus 4 pi is -2 pi. And thus the last one would be 2 pi plus 4 times -2 times pi. So why am I showing you all this? Just to explain, what does that n even mean there? It just means count by integers left and right if you want to find your asymptotes. That's all it's saying. And I could graphically show you that we did do this correct. You come over here and we were dividing by 4, I think. And so we had the asymptotes at 2 pi, 2 pi plus 4 pi n. And so here's our first one. If I move to the right and the left, you'll see that they all blend in. If I zoom in, there it is. So at 2 pi, 6 pi, 10 pi, 14 pi, -2 pi, -6 pi, -10 pi, all those would give us asymptotes. All right, I'm going to do part B, and I'm going to give you another DOL here. So again, same instructions, but I have a different transformation going on this time. Part B. Oh, let me get my ratios up. It says find the vertical asymptotes in sketch. I told you I'm going to just give you the sketch all day, just to be quicker. Number 1, what do we do first when finding a vertical asymptote?
Find the ratio.
Look for the ratio. So our ratio here is sine is y over h, cosine is x over h, tangent is y over x. For a vertical asymptote in math, not in math, just everywhere, what creates a vertical asymptote?
Dividing by 0.
When you divide by 0. So for this particular case, it means when x is 0. So that's what we're going to do second. We're going to go to the unit circle. And we're going to search for when does, let me do it in red to color coordinate, x equals 0 at, and we're going to go find that out. Well, we've already seen that. I promise I'll start giving you some different ones here in a second. X equals 0 at pi over 2. Also, again, 3 pi over 2, but I digress. Next, we're going to apply our horizontal transformations. So without a transformation, this would be very basic and simple. It would be the the vertical asymptotes would occur at x equals pi over 2 plus n pi. That's where they would all exist at. But we have transformations. This time, I'm not adding a b value. My b value technically is 1 right there. But this time, I have a c value. So the question you need to ask yourself, since 1 doesn't change the problem, what is my c doing? My c is, what's that symbol?
Adding.
Adding. What's the opposite of adding?
Subtracting.
Subtract. So what I need to do is subtract by pi over 2. Now subtracting is different. We don't subtract by distribution. You remember your old school rules? We multiply by distribution, that's correct. But we don't subtract by distribution. So what do I mean by saying that? I'm saying let's regroup these to make it easier. I'm going to have pi over 2 minus pi over 2 plus n pi. I just reordered it. What can you tell me about pi over 2 minus pi over 2? Yeah, go ahead and say it.
I was going to say they cancel.
They cancel. So it's just 0 plus n pi. Or you could even simplify that and just say x equals n pi. And throw on the n e double z. That means n is an integer. That would be my solution there. Okay, so what they did on their graph, if you check that out, is they pretty much put anytime you have a integer pi, so like -1 pi, -2 pi, 1 pi, what they did not include, and I will try to do it here, is I think this is my right color. I'll add that one in. That would be the first one. That's the 0. That would be x equals 0 from there. And these would be going across. So this would be a negative 1 pi. This would be a negative 2 pi. And that's when n equals negative 2. This is when n equals negative 1. This is when n equals 0, and so forth. N equals 1. X equals 1. Sorry, I got to move a zoom tool all the way. All right, back on it. Pi. There we go. Okay, after all that, it's time to see if you can do some algebra. You can obviously type this in the calculator and look at the graph, but I want you to come up and try to solve this problem now.